Welcome to The Explainer. Have you ever wondered how your body can possibly have a defense for every single germ out there? I mean, every virus, every bacteria, ones that exist now and ones that don't even exist yet? Well, today, we're going to break down that incredible story. We're going to follow the journey of a single immune cell from its creation, through its training, and right into battle. Let's get into it. All right, to make sense of this, let's start with a really simple idea. Just imagine your body is a fortress. And this fortress, it's under constant siege from all sorts of invaders. We're talking bacteria, viruses, you name it. To survive, you're going to need a seriously sophisticated defense system. And your fortress basically has two main lines of defense. First, you've got your wall guards. This is your innate immunity. They are always on, they react super fast, but, they kind of treat every enemy the same. Then, you've got the special forces. This is your adaptive immunity. These are the elite B cells and T cells. Now, they take a little more time to get ready, but they create custom-built weapons that are perfectly designed for one and only one specific enemy. And today, our story is all about one of those commandos, the B cell. Okay, so this brings us to a huge problem. If these B cells are our special forces, they need a unique weapon for every single enemy they could ever face. How in the world do you design a blueprint for a literally infinite arsenal? Yeah, this is the real head-scratcher. Your entire human genome has, maybe 30,000 genes, but your body can churn out billions of different unique antibodies. The math just doesn't work. You can't have one gene for every antibody. So what's the trick? How is this possible? The answer is it's pure biological genius. It all starts with something called combinatorial diversity. So instead of having a complete instruction manual for every single weapon, your DNA just keeps the parts in separate bins. Think of them like Lego boxes. You've got a box full of V pieces, a box of D pieces, and a box of J pieces. To build a brand new weapon gene, the B cell literally just grabs one piece from each box at random and snaps them together. And this isn't just total chaos. There's a method to the madness. It's like an assembly line. First, the cell builds the main part of the weapon, the heavy chain. It does that by joining a D piece and a J piece, and then snapping a V piece onto that. After that's done, it builds the smaller light chain by joining a V and a J. You put those two chains together, and bam, you've got a unique receptor. Just the sheer number of possible combinations here is astronomical. But wait, because this is where it gets even crazier and honestly cooler. There's a second process called junctional diversity. As those Lego pieces are getting snapped together, a special enzyme called TDT comes in, and you can think of it like a clumsy craftsman. It's intentionally a little sloppy. It randomly adds a few extra DNA letters right at the joints and maybe chews a few off. This messy connection process multiplies the number of possibilities into the trillions. So the key takeaway is that your body uses intentional, planned randomness to create a nearly infinite variety of weapons. It's amazing. All right, so now we have an arsenal with billions of unique weapons. But this creates a really dangerous new problem. What if some of these randomly made weapons just happen to target our own fortress, our own body? We absolutely have to have a brutal training program to make sure our soldiers don't commit friendly fire. And that training, that boot camp, happens in the bone marrow. A developing B cell has to pass a whole series of life or death checkpoints. As a pro B cell, its only job is to build a working heavy chain. If it succeeds, it graduates to being a pre-B cell, where it has to test that chain. And only if it passes that test does it finally get to build its light chain and become an immature B cell, ready for its final exam. Now, this final exam is called negative selection, and it is absolutely ruthless. Any B cell whose weapon reacts too strongly with our own body, a potential traitor, is dealt with in one of three ways. 1. It gets a second chance to rebuild its weapon, to try again. If that doesn't work, 2. It's ordered to self-destruct, apoptosis. Game over. Or 3. It's just permanently shut down, benched for life. Only the safest soldiers get to graduate. So the B cells that actually survive boot camp are now what we call naive recruits. They've proven they're safe, they have their unique weapon ready to go, but they have absolutely zero combat experience. They just circulate through your body, waiting for the one specific enemy they were literally born to fight. And when that day finally comes, activation can happen in a couple of ways. For most of the really complex bad guys, a B cell needs a second opinion. It finds the enemy, sure, but then it has to get permission from another special forces soldier, a helper T cell, before it can launch a full-scale attack. But for simpler enemies, ones with really repetitive patterns, the B cell can just activate on its own. It's a much faster response, but it's also a little less sophisticated. Once it's activated, the B cell travels to this incredible, specialized structure inside your lymph nodes called a germinal center. I want you to think of this place like a high-tech war factory. This is where our recruit truly begins its transformation into an elite veteran. Inside this factory, 3 incredible things happen. First, another enzyme, this one called AID, comes in and intentionally starts making tiny little typos in the antibody gene. This is called somatic hypermutation. Second, only the B cells whose typos accidentally made their weapon have a tighter grip on the enemy get to survive and multiply. It's survival of the fittest, and we call it affinity maturation. And finally, that same enzyme, AID, helps the B cell switch the function of its antibody, say from a general-purpose one to an armor-piercing one, all without ever changing its target. So how is all this coordinated? Well, cells use these special molecules called MHC to basically present intelligence reports. Think of it like a communication system. Most of the cells in your body use something called MHC class I, and that's their way of screaming, "An enemy is inside me, somebody kill me." But professional immune cells, like our B cell, use MHC class II, and that's their way of asking for help, of saying, "Hey team, look at the bad guy I found out here. Let's build a response together." So after weeks of intense refinement in that war factory, the battle is finally won. The invader is cleared out. The B cells that fought and survived are now battle-hardened veterans, and they're ready for their final assignments. And they differentiate into 2 absolutely crucial types of cells. Some of them become plasma cells. These guys are nothing but weapon factories. They give up everything else just to pump out thousands of perfect antibodies every single second. But others become memory B cells. These are the long-lived veterans who will patrol your body for years, sometimes for your entire life, carrying the memory of this one specific enemy. You know, what this all amounts to is just astonishing. It is literally a process of directed evolution happening inside your own body in real time. Random mutations get introduced, and the environment, the presence of that invader, selects for the fittest, most effective soldiers. It is a truly beautiful and ridiculously powerful system. So let's just quickly recap this B cell's incredible life story. First, the blueprint is created through random shuffling in the bone marrow. Then, the new recruit goes through a brutal boot camp to make sure it's safe. It gets activated by a real threat out in the world, goes to the war factory to get its weapons refined to perfection, and finally it deploys as either a mass production factory or a long-lived veteran guard. And this entire elegant process brings us to one final, really profound thought. If this whole system is designed to create a powerful army of veterans after a battle has already been fought and won, then how do vaccines work? How can we give the army the training manual and create those veteran soldiers without ever having to fight the real dangerous war in the first place? Well, that right there, that is the power of understanding this journey.